Hello and welcome to Math 2 Cypress High School Summer Program. In this video we'll be talking about Unit 6B Volume and Area, and I'm in Section 4, Composite Figures. Now I want you to read number 93 with me. Number 93 tells us how we are going to find the area or volume of a composite figure. So to find the area or volume of a composite figure, what we have to do is break the figure up into basic polygons, that's if it's a two-dimensional figure, or basic figures, that's if it's 3D. We're going to find the area of each piece, that is, each polygon or each figure, and then add those areas or volumes together. So what we have to do on all of these problems is take the picture and break it up into mini problems, break it up into mini triangles and mini rectangles, and mini cylinders and mini cones, and take those little cylinders, cones, triangles, and rectangles, find the area or volume of each, and then add those area and volumes together. So on each picture I want you to start visualizing what type of line you can draw on the picture to create two basic figures. On number 94 I'm looking at that and I'm saying, alright, I can take that figure and break it up into two separate rectangles. And I kind of have two options. I can either connect this line down, so by connecting it there, I have this rectangle, and I also have this rectangle. So that's two separate ones that I can find the area of each and add them together. We're going to do problem number 96 together. Number 96 is a rather complicated problem, and there's a couple steps that I'd like to cover with it. So I'm going to look at 96 and figure out what two shapes can I divide 96 into. Right away I notice that this bottom shape, if I connect that line right there, this bottom shape is a rectangle. Four sides, they all look like 90-degree angles, so I'm going to assume that's a rectangle, which leaves me with this top shape up here. And this top shape is almost a circle, but it's only half of a circle. So I'm going to label this top piece as half circle. And I'm going to label the bottom piece as a rectangle. Now what I'm going to do is find the area of each piece individually. I'm going to find the area of the rectangle first, and then the area of the half circle. And then I'm going to add those two areas together to give me the entire picture's area. So let's start with the rectangle. The formula for the area of a rectangle is A equals base times height. That is the formula for the area of a rectangle. So I need to find my base and my height of this rectangle right here. Well, there's only two sides given, and it looks like one of these down here I can call the base, that's 4, and this 6 I can call the height. They form this 90-degree angle right down here. So my base and my height are 4 and 6. I'm going to plug them into the formula. A equals my base, 4, times my height, which is 6. And 4 times 6 gives me an area of that rectangle, 24 centimeters squared. And I'm just going to put a little 24 inside here. That's my area of that rectangle, so I remember. Now I also have this half circle to work with. The area of a circle is A equals pi times r squared. So I'm going to start with that and say, alright, I need my radius of this circle. And the radius is this piece right here. It starts on the edge of the circle and goes to the halfway point. Now that's not labeled, so I need to look down here and say, alright, this whole thing, this whole yellow line, and I'm actually going to make that, let's go blue. This whole line right here is 4. That's labeled right here as 4. Now this whole line is going to be the same as this whole line, so this whole line, they're both the same length, are both 4. That is the diameter of the circle. It starts on the circle, ends on the circle, and goes through the center. So this 4 is a diameter. To get the radius, I need to divide this 4 by 2. 4 divided by 2 is 2, so my radius is equal to 2. Now I have the radius of that circle. I need to plug it into the formula. A equals pi, which is 3.14, times my radius, which is 2, squared. Now I'm going to find the area of that circle, with the calculator. 3.14 times, and I have 2 squared, so 2 times 2, which equals 12.56. I can round that to be A equals 12.6. And we are in centimeters squared. Now that area is of an entire circle. It is not just half of a circle. Right here, this whole spot, let me erase some of this so we can see it. This is only half of a circle. So to find the area of half the circle, I'm going to take the area of the entire circle and divide it by 2. That's going to give me this half circle right here. We've already found this area down here as a part of the 24 rectangle. So I'm going to take this 12.6, divide it by 2, and the area of my half circle will be 6.3 centimeters squared. So my half circle is 6.3. Now to find the area of the entire figure, I'm going to add those two mini areas together, 6.3 and 24. So the area of my whole big piece, A, equals 24 plus 6.3, and 24 plus 6.3 is 30.3 centimeters squared. And that is the area of the entire figure. We find the area of one piece and add it to the area of the other piece. Now that's a two-dimensional shape. 94, 95, and 96 are all two-dimensional shapes. 97, 98, 99 are three-dimensional shapes, so we're going to have to find the area. The same concept, but we're finding the volume now of two different figures and adding them together. I wanted to take a look at number 99. This one is a pretty good problem, so I wanted to cover it with you. Right here, we need to break this up into two different figures. The first and easier one to find is this cylinder. That's a cylinder right there that I've highlighted in blue. That's a cylinder, so I'm going to draw a little arrow and say cylinder. Now on top, I need to look at what's on top, and that's this right here. And on top is a sphere, but it's only half. That's half of a sphere. If you took a ball, cut it in half, and set it on top of the cylinder, that would be a half sphere sitting on top of that cylinder. So again, we have half of something. We're going to find the volume of that entire sphere as if it were to go all the way down here and divide it by 2. So let's find the volume of this cylinder first. This cylinder we had in blue right here, not anymore. But a cylinder, the volume has a formula, V equals height times pi times radius squared. So we need to find the height and the radius of this cylinder right here. Now the radius goes from the edge of the cylinder all the way to the center, and it's given to us right there. Our radius is 3. Fairly easy, it's already given to us. And the height tells us how tall it is. This cylinder is 10 centimeters tall. That's my big height. So I have the two pieces I need. I'm going to plug them directly into the formula. V equals my big height of 10 times pi, which is 3.14, times my radius, which is 3, squared. So I have this formula. I just need to plug it into a calculator to solve. 10 times 3.14 times my radius of 3, and it's squared, so I'll multiply 3 again. 282.6, so the volume of this is 282.6. I guess we'll leave it like that. Didn't know we could do that, but we'll work with it. Not anymore. So we have the volume of that cylinder. It's 282.6, and we're in centimeters cubed. Volume is in cubed. So this cylinder right here, 282.6. Now we just need to find the volume of the half sphere. The sphere volume formula is V equals 4/3 times pi times radius cubed. Don't know what happened. Bring it back down. Looks better. Radius cubed. So we have this half sphere. and we need to find the radius. Well, the radius of the half sphere would be up here, and it would be a line that goes from the edge to the center. Down here we already have that labeled as a radius, which is 3. So my radius, again, is the same up here, which is 3. So r equals 3. So I'm going to plug this 3 into the radius. So I'll rewrite this formula using 3 as my radius. V equals 4/3 times 3.14 for pi times my radius, which is 3, cubed. So I write that out, and now I'm going to plug this into the calculator. 4 divided by 3 times 3.14 times my radius 3, and I'm multiplying it 3 times. So 1, 2, 3 equals 113.04. 113.04. I look at this 0 and say this 4 either rounds it up or keeps it the same. Because that 4 is less than 5, it keeps it the same. The volume is 113.0, and we're in centimeters cubed. So the volume of that half sphere, or excuse me, the volume of an entire sphere is 113. But we're not working with an entire sphere, we're only working with half of a sphere. So we're going to take our volume and divide it by 2. So 113 divided by 2 is going to give us 56.5. The volume of that half sphere is 56.5 centimeters cubed. So this is 56.5. And I have now the volume of the half sphere, 56.5, and the volume of the cylinder, 282.6. I need to take those two pieces and to find the volume of the entire figure, add them together. So V volume of the entire figure is equal to 56.5, that was the half sphere, plus 282.6. And that's going to give me a final answer of 56.5 plus 282.6 equals 339.1, and we are in centimeters cubed. So again, it's the same idea. We're going to take two different pieces, find the area or volume of each, and then add them together to get our final area.